In Mod 11, we are going to look at solving trig equations. And the first thing that I have given you is some tips to use when you are solving trig equations. First of all, if the equation is linear, meaning it's a sine, a cosine, a tangent, the function is raised to the first power, solve for that function. Get the function by itself. The second tip, if the equation has multiple occurrences of the function, there's more than one term that has the sine in it or that has tangent in it, set the equation equal to 0 and try factoring. Third tip, if the equation contains reciprocal functions, set the equation equal to 0 and then multiply the entire equation by one of those functions to eliminate the reciprocal function. And the last tip, if the equation contains two different trig functions, but one of the functions is squared, see if replacing that squared function with a Pythagorean identity will help you solve the problem. On the first set of equations that we are going to solve, the directions tell us to solve the equation over the interval from 0 to 2 pi, with 0 being included and 2 pi not being included. What these directions mean is that when you solve your problem and you are deciding what angle your answer should be, you need to write those angles in radians. Our first example is a very, very basic equation to solve, and we have the sine of x plus 2 equals 3. The only thing that has the variable in it is the sine function. So what we are going to do is get that sine function by itself. So just like any other algebraic equation, we are going to subtract 2 from both sides, and we now get the sine of x equals 1. Once you have the sine of x or the sine of theta, whatever they are using for the argument, the function equals a number. You are now ready to write your answer. Your answer always gets written as argument equals because you're saying what angle gives us a sine value of 1. So think about this. What angle has a y value of 1? There is only one of those. That happens when x equals pi over 2. So you always, for your answer, write argument equals and then the angle measure. On our second example, we have 2 times the cotangent of x plus 1 equals negative 1. The first thing we need to do is get the trig function, cotangent of x, that term by itself. Right now it's got a plus 1 with it, so we are going to subtract 1 on both sides. And now we have 2 times cotangent of x equals negative 2. You need cotangent of x to be all by itself. It can't be times anything or have anything added to it. So we are going to divide both sides by 2. Now we have cotangent of x equals negative 1. So now we have to ask ourselves, what angle or angles, there may be more than one answer on these, will have a cotangent of negative 1. Remember, we talked about that cotangent and tangent are negative in quadrant 2 and in quadrant 4. So if you look at your unit circle in quadrant 2 and quadrant 4, and then think about putting the x value over the y value, because remember, we said cotangent is x over y. Are there any angles where by putting x over y, I'm going to get negative 1? Yes, that happens in 2 places. That happens at the over 4 angles in each of those quadrants. So to write our answer, we say the argument equals the angle in quadrant 2 is 3 pi over 4, and the angle in quadrant 4 is 7 pi over 4. On example C, we have the tangent squared of x minus 3 equals 0. We still only have one occurrence of the function. It is a squared function, but that's okay. Our process is going to stay the same. We still want to get the function by itself. So we are going to add 3 on both sides. Now we have the tangent squared of x equals 3. Well, we don't want tangent squared. We want tangent. How do you get rid of a square? You take the square root. So we are going to take the square root of tangent squared of x equals, and over here on the right where we had a number, we have to do plus or minus the square root of 3. Taking the square root of a square leaves you with just the first power, tangent of x, equals, and we can't simplify square root of 3, so it stays plus or minus square root of 3. Well, now, because we have both the positive and the negative, we have to think about in all 4 quadrants, if we put y over x, is there somewhere we will get an answer of square root of 3? And there is. There are 4 places where this happens. This happens at the angle of pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. On D, we have 2 times the sine of x plus 3 equals 4. So we have to get the sine function by itself, which means first we're going to subtract 3 on both sides and have 2 times the sine of x equals 1. Then divide both sides by 2. So now we get the sine of x equals 1/2. So where is the sine function positive? That happens in quadrants 1 and 2. In quadrants 1 and 2, what angles have a y value of 1/2? That happens at the angles of x equals pi over 6 and 5 pi over 6. On example E, we have the quantity of cotangent x minus 1 times the quantity of the square root of 3 cotangent of x plus 1 equals 0. I want to go back a little bit. If you had an equation that just said x minus 1 times x plus 1 equals 0, how would you solve that? You would set each one of those parts equal to 0 and solve it that way. This problem is exactly like that, except for the fact that it's got cotangents in it. So the process that we are going to use is exactly the same as if we had this x minus 1 times x plus 1. So we are going to take each of those quantities and set them equal to 0. So we're going to do the cotangent of x minus 1 equals 0 and square root of 3 times the cotangent of x plus 1 equals 0. What this does is just give us 2 equations that we have to solve. On the left-hand equation, we just need to add 1 on both sides and it will be solved. So cotangent of x equals 1 is our first. Where is cotangent positive? That's in quadrant 1 and quadrant 3. Where does cotangent equal 1? At the over 4 angles. So the solution for our first equation will be x equals pi over 4 and x equals 5 pi over 4. So we have solved the first of those. Now come over to the second one. First thing we're going to do is subtract 1 on both sides. So we have the square root of 3 times the cotangent of x equals -1. Divide by that square root of 3. We're dividing by the coefficient to get the variable by itself. So we're going to have the cotangent of x equals -1 over square root of 3. So on this equation, our cotangent is negative. That happens in quadrants 2 and 4. If you put the x-coordinate over the y-coordinate, where do you get -1 over square root of 3? Well, that happens at the angles of 2 pi over 3 and 5 pi over 3. So you wind up with 4 solutions to this equation. On F, we have 2 times the secant of x plus 1 equals the secant of x plus 3. What this is similar to would be if you had 2x plus 1 equals x, as in equals, plus 3. You would subtract x from both sides first to get x's on one side, numbers on the other. So we're going to do the same idea on this problem. We're going to subtract secant of x from both sides. So 2 times the secant of x minus 1 secant of x will leave you with 1 secant x plus 1 equals 3. We are going to subtract 1, and we now have secant of x equals 2. Secant is the reciprocal of cosine, and that's positive in quadrants 1 and 4. If the secant is 2, what you have to remember then is that the cosine is 1/2. So in quadrant 1 and quadrant 4, what angle or angles has a cosine of 1/2? Well, that happens when x is pi over 3 and 5 pi over 3. On G, we are back to a very simple equation, this time involving only the tangent function. We want to get the tangent function by itself. So we are going to subtract 1 on both sides. So we get the tangent, our variable this time is theta, equals -1. Where is tangent negative? Quadrants 2 and 4. Where does tangent equal 1 or -1? It's always 1 or -1 at the over 4 angles. So in quadrant 2, the theta we would be talking about would be 3 pi over 4. And in quadrant 4, it would be 7 pi over 4. On example H, we have the square root of the quantity 1 plus cosine x equals the sine of x. Well, in a problem like this, you want to get rid of that square root symbol. How do you get rid of a square root? You square it. So we are going to take our square root of 1 plus cosine x and square it, but you have to do the same thing on both sides of the equation. So we are also going to square our sine of x. When you square a square root, they offset each other, cancel if you will, and you would be left with just 1 plus cosine x. Squaring the sine just gives you sine squared x. So what happens now is we got rid of the square root, which is great, but now we have two different functions. So what we are going to do is think about the fact that we have a Pythagorean identity that uses sine squared and cosine squared. We can replace the sine squared function using a cosine squared function, and then we will have the same function throughout. So the left side of the equation is not going to change right now. The right side we are going to rewrite by what we know about sine squared, that it's equal to 1 minus cosine squared of x. So now we're in good shape because we do have the same function all the way through. When you have the function in more than one place and they are two different powers, then you need to get everything on one side and factor if you can. So first thing we are going to do is subtract 1 on both sides. So now we have the cosine of x equals the negative cosine squared of x. Well, we want our squared terms to be positive. So we are going to add cosine squared of x to both sides. Well, those are not like terms, so they have to stay separate terms and be cosine squared of x plus cosine x equals 0. We need to do another callback to algebra. If you had x squared plus x, you can factor out an x and make it x times the quantity x plus 1. We are going to do exactly that same thing here, but we are going to be doing it with cosines. So we are going to factor out cosine x. If you take cosine squared and divide it by cosine x, you still have one of the cosines of x. For the second term, if you take cosine of x divided by itself, you have 1 equals 0. Well, now we take each of those items and set them equal to 0. Cosine of x equals 0 and cosine x plus 1 equals 0. So we have two equations that we have to solve here. The equation on the left is already solved. It says cosine of x equals 0. So you have to ask yourself, at what angle or angles is the x value 0? That happens at two places. That happens at pi over 2 and 3 pi over 2. So that equation is done. On the right side, we have to add or subtract 1 from both sides. And we now have cosine x equals negative 1. So now you have to ask yourself, where on the unit circle is the x coordinate negative 1? That happens only at one place, and that is at pi. On example I, we have negative 1 minus the tangent of x equals the secant of x. On this problem, we have two different functions. Neither one of them is a square. So right now, we can't use Pythagorean identities in any way to help us. But if you think about the Pythagorean identities, we do have a Pythagorean identity that uses tangent squared and secant squared. So what we're going to do to create squares is square both sides. So we are going to square -1 minus tangent of x, and we are going to square just the term secant of x. Be careful, because on the left, when you have -1 minus tangent of x squared, remember that means that you are taking that quantity times itself. And that is going to take FOIL. So if we take the first times the first, we're going to get 1. If we take the outsides times each other, we're going to get plus tangent x. Take the insides times each other. We get another plus tangent x. And then take the last times the last, you get plus tangent squared of x. And on the right side, when you square that secant, you get secant squared of x. So my left side of the equals becomes 1 plus 2 tangent of x plus tangent of squared of x equals secant squared of x. All I did was put my two like terms, tangent x plus tangent x, together. So we now still have two different functions. And we can't do anything with the tangent functions because we have a tangent to the first and a tangent to the second. So the function that we are going to have to replace is the secant squared using our Pythagorean identity. So what we will get by doing that is 1 plus 2 tangent of x plus tangent squared of x equals, the substitution will be tangent squared x plus 1. Now you need to get everything on the same side equal to 0. So we're going to subtract 1 on both sides, and that they will cancel out and leave us with 2 tangent x plus tangent squared x equals tangent squared x. Well, now we still don't have it equal to 0, so we are going to subtract tangent squared x on both sides. So now we have 2 times the tangent of x equals 0. Get the tangent function by itself by dividing by 2. So now we have tangent of x equals 0. Well, where does the tangent equal 0? If you put the y value over the x value, where do you get 0? That happens at the angles of 0 and at pi. We do not say 2 pi because we already said 0. And remember, our very beginning directions said that 0 is included, but 2 pi is not included. So we stop in 1 revolution. This is our last example for in 1 revolution between 0 and 2 pi, and our equation says the sine of 2x plus 1 equals 0. So notice that your argument is different. On these problems, you still get the function by itself. So the first thing we're going to do is subtract 1 on both sides. So now we have the sine of 2x equals -1. So think about what we've been doing all along. As soon as we had function equals number, we found out what angle that happened at. So we're going to do that here. What angle has a sine value, a y value of -1? That happens at 3 pi over 2. So remember what our pattern has been. It has been argument equals angle. So that's what we do on these problems, is we first just solve it for the angle and get argument equals angle. Now we need 1x, not 2x. So how do you get rid of that 2? You divide by 2, but my right-hand side is already a fraction. So remember that dividing by 2 is the same thing as multiplying by 1/2. So x equals 3 pi over 4 is my final solution. You are not done until you have solved your argument and made it say just x equals.